All right, here's the quad ramp. We were talking about this in class. Got 4 tracks: red, green, yellow, blue. They all start at the same height. They all end at the same height. So the question we had was, what would the speed be at the bottom? How do they compare? So based on energy, starting at the same height, ending at the same height, you went from PE to KE, and you should end up at the same speed at the bottom. Now we're going to try each of these ramps. We're going to release the balls. Use our little copper pipe to get these things set up. Oh, hold on one second. There we go. Here they are. We're going to release them. And what you will find is you can try to predict, pause the video, which one's going to win the race to the bottom. And let's see. Maybe they all get there at the same time if we claim they all get there with the same speed. Ooh, no. They did not get there at the same time. You can go back and check the video again if you want. But it went blue, yellow, green, red. And so now that you know that, seeing blue, yellow, green, red second time around will be very easy to spot. We'll show it once more. Boom, there it goes. It should arrive in order from right to left. Let's see. Yep, look at that, knocking them on the ground and everything. Oh my goodness, look at this mess. It's like an on top of spaghetti moment. Okay, so we got another setup down here, which we're gonna check out in just a moment. But talking about this blue, yellow, green, red, can you see why it is that one would get down here before another one? Actually, it's a pretty simple reason. If you notice, the blue, maybe the side view, the blue drops down first. PE turns to KE first. Height turns to speed first, so it's spending most of its time at high speed. The yellow and the green are pretty similar, although yellow turns into speed first, and then the red hangs out up high for a long time, PE, 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 and then it drops to KE at the last moment. So our claim is they travel the same speed at the bottom, but they don't all take the same path to get there. Now let's see if we can actually vindicate that claim. Can we actually prove that they do leave here at the same speed? We have 2 meter sticks set up here, and we have a 3rd meter stick crosswise. This is set up horizontally to be about 65 centimeters off the wall. Okay, there's your wall. Good. So they're all going to leave here. Now the key is, if they do in fact leave at the same speed, they should not strike the ground at the same time. We saw that they are not going to leave here at the same time. But they should travel the same horizontal distance off that ramp onto the ground. And of course, in the name of video efficiency, the balls came off the table. Oh, there it is. It was hiding from me. Okay, so let's see. Let's set our ramp up. Put our 4 balls up here. Okay. So now what we're going to look for and listen for is, do all 4 balls travel the same distance from the end of the ramp? Do they all actually come off the table and reach the same distance on the ground? Hopefully that distance is where I preset the ruler, the meter stick. You'll hear 4 clicks if so. All right, say it. Ready, set, go. Woo! I heard 4 clicks. Did you hear them? I gotta find those